In this video, we are going to see operating system scheduling queues. The OS maintains queues to sort out the scenario that which process is waiting and for what kind of operation it is waiting. The queues are as follows. First is the job queue. If many processes enter a system, the system assembles it in the job queue. The system stores the job queue on the mass storage device, that is the secondary memory. Then next is the ready queue. If a process is ready for execution, then OS brings it to the ready queue, that is it in the main memory. The processes in the ready queue are the ones waiting to get the CPU cycle. Next is the device queue. This the separate device queue for each I/O device is maintained by the OS. This device queue holds the processes that are waiting to perform the I/O on that particular device. Both the device queue and ready queue maintain the process control block of that is this PCB that stores the relative informations like the process ID, process state, process priority, and the program counter. Program counter, we know that is a register in the CPU. Then next is the we come to the scheduling sequence. The process that is ready for execution is brought to the ready queue from the job queue. In the ready queue, it waits until the scheduler allots the CPU to the process. Once the process gets the CPU, the execution begins and the following sequence may take place. Seeing this diagram, we can easily understand what is the sequence that happens when the process is put in the ready queue. While execution, the process may create a new process. Then the system suspends the parent process until the child process terminates. Once the child process terminates, the parent process is put back into the ready queue. That we can see it from the diagram. If the time allotted to the process for execution gets expired and if the process execution isn't completed, then the scheduler puts it back in the ready queue. Then, if an interrupt occurs during the execution, the process suspends its execution. It handles the interrupt first and then puts the process back in the ready queue. During execution, if the process wants to perform an I/O, the system stores it in the device queue. After it completes its I/O operation, the system puts it back into the ready queue. That is we should know the process that is ready for execution is in the ready queue. If the process completes its execution, the processor terminates it and it deallocates the PCB related to the process. It also releases the resources allotted to the process. Subscribe to my channel if you feel contented.